Hello, welcome to Anybody Can Learn. Today we will learn linear regression. Before that, we will understand what is a machine learning. Machine learning is a branch of artificial intelligence, that is AI. It enables computer to learn patterns from the data. Computer make predictions without being explicitly programmed for every situation. Instead of writing rules manually, we give the computer many examples. The computer learns the relationship between the inputs and output. Real life examples is computer predicting the price of the house. Computer can predict students' mark or predicting the tomorrow's temperature or predicting the price of the stock. What is a regression? Regression is a machine learning technique and it is used to predict the continuous numerical values. Regression is used whenever the output is a continuous value. For example, the house price prediction, its output value is 65 lakhs. It is a number. So predicting the temperature whose output is, for example, is 32.5 degrees Celsius. Again, the output is a number. Salary prediction whose output is 8,50,000 rupees. It is a number. Weight prediction, again the output is 72 kg. It is a number. So regression is used whenever the output is a continuous value. What is a linear regression? Linear regression is the simplest regression algorithm. It assumes the relationship between the input and the output is a linear. That is, it can be represented by a straight line. For example, study hours versus marks example. If you study for 1 hour, you may get 35 marks. If you study for 2 hours, you will get 45 marks. For 3 hours of study, you will get 55 marks. For 4 hours of study, you will get 65 marks. And for 5 hours of study, you will get 75 marks. As a study hours increases, the marks also increases. So it increases almost linearly. A straight line can model this relationship. So this is a linear regression model. The goal of the linear regression is to find the best straight line that fits the given data. Once we find this line, we can predict the output for new inputs. So, for example, suppose we have the best fit line for study hours and marks. We can use it to estimate the expected marks for a new student. For example, if a student studies for 6 hours, we can predict their score. Linear regression formula for one feature is y hat is equal to wx. This is the simplest linear regression model formula. Y hat means the predicted value produced by the model. For example, actual marks are 80, but the model predicts the mark as 78. Then that 78 is our y hat. X is the input feature. For example, house size, study hours, age, weight, etc. And W is the weight. It is also called as a parameter. Weight tells us how much prediction changes when the input changes. For example, suppose we have given a data. In that data the weight is 5. Our model become y hat is equal to 5x. Now we can predict if the input x is 2, then y hat is 5 into 2, that is 10. If the input x is 6, then y hat is 5 into 6 is 30. Why it is called linear? The straight line, because the equation y hat is equal to wx represents a straight line. If we plot it, we will get a line. For example, plot y hat is equal to wx, where x is our input and y hat is a prediction. If x is minus 2, then y hat is minus 4. If x is minus 1, then y hat is minus 2. If x is 0, then y hat is 0. If x is 1, then y hat is 2. If x is 2, then y hat is 4, because our equation is y hat is equal to 2 into x. That means 2 multiplied by minus 2 will give minus 4. 2 multiplied by minus 1 will give minus 2. 2 multiplied by 0 will give 0. 2 multiplied by 1 will give 2. 2 multiplied by 2 will give 4. And if we plot this point together, we will get a straight line. Therefore, it is called as linear. Why do we need a transpose? If we have multiple features, then the prediction is calculated using a dot product. For example, a house has two features, size and number of bedrooms. Then we can write the feature vector x as a column vector with entries 1000, that is size, and number of bedrooms as 3. Suppose our weight vector w is a column vector with entries 50 and 100. Then we will calculate the prediction as W transpose x. W transpose because in this example we have multiple features. Here we have two features. Now W transpose is row vector 50 and 100 multiplied by x, that is column vector 1000 and 3. So 50 multiplied by 1000 plus 100 multiplied by 3, it will give 50,000 plus 300, that is W transpose x is a 50,300. In case if we have a one feature only, that is in our assignment we have one feature, then we will use the formula as W transpose x is equal to 2 into minus 1 is equal to minus 2. The universal rule is that if we have one feature, then W transpose x is a Wx, because the transpose does not change the result. This is because each vector has only one element. What does the model learn? The learning process is, initially the weight is chosen randomly. For example, W is equal to 2. At first, the prediction may not match the actual values. Then, gradient descent update the weight repeatedly. For example, if we choose the weight initially as a 2, then gradient descent will update this weight repeatedly. After first iteration, it will produce -4 as a weight, then it will update weight to -1.5, then 3.2, and thus goes on. Eventually, it finds a weight that minimizes the prediction error. So what is the error? Error tells us how far the prediction is from the actual value. Error is calculated by the formula y minus y hat, that is actual value minus predicted value. Y means actual value and y hat means predicted value. For example, if the actual value is 10 and model predict the value as 8, then the error become 10 minus 8, that is error is equal to 2. What is a square error? The formula of the square error is square of y minus y hat. For example, if the error is 2, then square it. So 2 square is 4. It is used, that is square error is used to ensure errors are always non-negative. Square error help to penalize large mistakes more heavily in a linear regression. What is loss function? The loss function measures the total prediction error over all the training examples. L of W is equal to summation of square of yi minus y hat of I. Yi is our actual value, whereas y hat is a predicted value. The goal of the training is to find the values of W that makes this loss as small as possible. That is, the goal of the training is to find the weight which makes the loss as small as possible. Thank you.